Hello friends, myself Vipul Patel. In this session, we are going to discuss on 6-step inverter based drive. In the diagram, you can see this is the input supply, this is the three-phase control rectifier, this is the alpha control for it. The output of three-phase control rectifier is given to the three-phase square wave inverter, and the output of three-phase square wave inverter is 6-step square wave, and that output is given to the motor. These are the control parameters. The output of waveform of inverter is a 6-step waveform. This is to reduce the percentage of harmonic in the inverter output. A low percentage of harmonic will reduce the motor heating and the problem like torque pulsation. Both the output frequency and voltage of inverter should be variable. In order to vary them simultaneously to keep the ratio even F1 constant, a common control voltage Vc is used to vary both F1 and alpha as shown in previous diagram. Now, operation. In order to vary the output voltage of a square wave inverter, a variable DC voltage is required on the input side of inverter. This is obtained from a converter filter combination on the input side of the inverter. The output frequency of the inverter can be changed by changing the rate at which the device connected in the inverter are switched on and off. The VCO frequency will vary in proportion with the DC control voltage to vary inverter output frequency. Now, the transfer characteristic means input-output characteristic of flux control block is shown below. From this graph, you can see this is the output voltage, this is the input voltage, and this is a base speed. Below the base speed, the E1 and F1 means stator voltage and frequency is constant, and after the base speed, the voltage will be only constant. This will provide the required voltage boost at low frequency. Then the linear region correspond to the constant E1 F1 region, and then the constant output voltage region correspond to the constant power region of operation. The firing angle of three-phase converter is in proportion with the output voltage of flux control circuit. The control voltage Vc is obtained from a ramp function generator, that is RFG. The characteristic of RFG is shown below, where you can see the ramping up and ramping down, how this will generated. The RFG output will follow the changes in its input voltage gradually and not instantaneously. Therefore, the control voltage Vc will increase as well as decrease gradually. Thus, this will ensure a gradual acceleration and deceleration of the motor. The process of gradual acceleration is known as ramping up, and the gradual deceleration is known as ramping down. The RFG also provides the soft start required at the time of starting the induction motor. Now, torque slip characteristic. The torque slip characteristic for VF control induction motor is shown below. In this graph, you can see torque versus slip and speed characteristic At the right side, the N1, N2, N3 indicate the speed is decreases, and also this right side frequency will decrease. So from this graph, with increase in F1, the graph shows that with increase in F1, the characteristic gets shifted toward left and the speed increases. As in graph, you can see the frequency is increases, the graph is shifted and speed is increases because this N1 is higher than the N2 and N2 is higher than the N3. So if the load torque TL is constant, then the speed goes on decrease in the stator frequency F1. Now the control characteristic. Below figure shows the control characteristic of VF control scheme. In this graph, you can observe this is the stator voltage and stator frequency, where you can see the graph is linear graph. This graph shows that the stator voltage is increased linearly with the increase in stator frequency to keep the VF ratio constant. Now, the advantages of VF control. Smooth control of speed, air gap flux remain constant, so no possibility of core saturation. It is possible to get a concept maximum torque at all the speeds, right from 0 to rated speed. Now, the disadvantages are control circuit is complicated. Second is it is possible to use the output of this inverter for any other applications. Thank you for watching this video.